Hello, this is Pete from GS2 once again. Working on another project now. I'll try to get through the intro fairly quickly. I'm going to be building another stereo preamp for a home stereo system. Its predecessor to this one I built, I think I got a video out there on it, not that that's all terribly important, but it basically had a series of inputs, volume control, and then in the tone stack it only had a treble and a bass, where this one has treble, mid-range, and bass, which I think I tried to build this one a few years ago and didn't quite work out, so I kind of gave up on it. This one also has a balance control, and then it goes to a plate follower impedance drop on the way out, and then I add a little hum filter at the very end because I've seen this in the past where I typically have some low frequencies, so I just do a variable resistor pot tied across that I can run across a particular size of capacitor, and I can take out that 60, 70, 80 hertz hum that I'm not going to send through anyway. So it works off 300 volts DC. Again, pretty straightforward as you go through it, using a 12AU7 here as the input tube, goes to the tone stack balance control, then it cuts out of that, amplifies it, and then it takes it eventually out to a RCA connector that'll eventually go to an amplifier. So I take that schematic and I convert it into something that I just call a layout drawing or a build drawing, and I'm going to put this all these components, the resistors, capacitors, on a blackboard plate turret mount sort of scenario. And here I show the same. I show the input selector switch going up to a volume control. That all goes over to a 12AU7. Then it goes to the tone stack. Balance is in there somewhere right after it. And then I go through this plate follower here, and then I eventually take it out to the outside. So that's pretty much how I'm actually physically going to build it when I put it on the board, and then the board actually goes in the enclosure, the chassis. Continuing on with this preamp project, got one of the channels, like this is the right channel that I've got the board built in there. I'm actually floating in and out a couple of the capacitors on the tone stack on the treble side to see. I want to get that good feel for it. I was a little bit too tinny when I first set it up per the original design, so I'm kind of changing those as I go. And then this is the back side of the underside of the power supply. I'm only using one side of it right now. The other side is not connected up. But that's what the whole thing kind of looks like. I did try to use a 12 volt DC supply in this. It was a switching DC supply. I was going to use 12 volts to light the heater elements on the 12AU7s and 12AY7 triodes. It came off a little dirty, so I went back to using the 6.3 AC tap that comes off the transformer. So all in all, pretty much getting this one kind of fine-tuned in a little bit. So I'll put labels on it later so I can see what the BNCs are on. I actually got it hooked up to something I did want to notice. I picked up a little hum in this one. I'm going to bring a little tighter in this one here. I picked up a little hum, low frequency hum, and hard to say where it's coming from. I probably could do a little better job in my power supplies, but nonetheless. So I had come up with this idea some time ago using a pot and a capacitor of some value. I think this is 0.1 microfarad, and it uses pretty much just a high-pass filter, adjustable high-pass filter. I call it a hum filter, and I just kind of set this up on a little temporary strip right here so I can plug it in there, play around with it, get it to where I want it to be, and I'll probably hard mount that in the side of the box here so I can adjust it once it's in place. I've done this before where I use a hum filter to take out some noise that comes in there. There are a couple places I could put some 1 microfarad electro caps along the power rail, B plus line, to a ground. That would help. So anyway, that's that's what's going on that. Then I'm actually started to populate the second board. This would be for the left-hand channel, and that'll go right on top of this one, of course, when I'm done. So it's coming along. All in all, is I expect little. That's the nice thing about using these blackboard. I can do substitutions. So there was a couple capacitors on the treble side that I just made a little bigger using mica capacitors to get. It was a little bit too tinny. They were calling for a 220 pico, and I brought them up to a 390 just to see how it sounded. And actually, it sounds pretty good. So all that said and done, it's coming around, and got the second board, the left-hand channel, built and installed. I was able to fire it up and got put a, I don't know, a 3K sine wave through it, and was able to adjust the volume and check the balance knobs, and it seems like it works okay. So that's kind of where it is. I'm going to put labels on this thing, turn it upside down, put a bottom on it. Much the same for the power supply. I just temporarily connected the second side in with the wire nuts. I'll do a better connection on that, and then put a bottom on this thing and put some labels on it. I'll check my current draw to make sure I'm got the appropriate fuse in there. So pretty much at this point in time, I'm going to call this project close to the end. I'll probably do one more segment on here, and I'll put some of the results up on the screen, and we'll go from there. Just want to break away real quick for a little safety stuff here while we're using voltages that can hurt us, kill us. And so I saw this thing on a couple of the guys that some of these the guys who do amp restorations come up with these things too, and you've seen them out there. I think I first saw it on Dave Carlson, Mr. Carlson's lab. Good stuff. You learn a lot there. And basically, it takes the input from the mains, runs it through the light bulb before it comes out the outlets that you're going to plug into. Again, this is all 120 VAC. And you turn the switch on, so if there's a dead short, the light lights up. It doesn't zap you, it doesn't cause the arc, it doesn't blow fuses out. You could save yourself some money on fuses with this, and just a good safety feature to have. You can find these things out there, as you know, on some of the internet YouTube sites out there. So worthwhile building, having one around, and I use it all the time. Well, completed the project. Just put it all together for last time. Then I had to install what I call a hum filter. It's kind of hard to see in that little corner there, but it's basically a high pass filter. It looks just kind of like that. Input capacitor going down to the ground. Variable resistor pot that I just wired across in the output, and that pretty much can take the hum out. I picked up a little, I don't know, 40 to 60 hertz hum that came out of it. I was actually going to show it up on one of my scopes I can do a FFT on, fast Fourier transform, and it was such a small little signal. It really wasn't. I spent more time trying to find to actually show the signal. This is the power supply. It's a dual power supply that feeds one transformer feeds the left side, one feeds the right hand side. So I'm going to turn this thing back over and then take one look at the last in the project, and then we'll call it done. And just before closing the project down, I was able to take my schematic out and then document what my B plus major voltage was, what I saw on the V1 and V2 tubes. These were 12AU7. This one here is a 12AY7. So I was able to mark them down and keep track of them, so in case something changes or it doesn't work the way it used to, I can always go back as a reference and see what happened. But this is kind of what it looked like in the very end. I was able to get some labels on it in the front, labels on the back. Got my hum filter on the side so I can get rid of some, and it actually works quite well. And this, of course, is a dual power supply. So calling this project done. And as usual, it didn't start on fire and I didn't get zapped, so call it a success. It's always fun to do these things. And for anybody out there doing this sort of stuff, just be careful, ask questions. When in doubt, use one of these safety things over here. I use these things even to this day when I'm working on something that I built, but good idea to have them. You can, I think I mentioned in a previous segment of how you can get these things built where the light bulb. If there's a dead short, the thing comes on and will save it from getting zapped. So once again, successful project, Pete from GS2.